All right, so that one ended up being x equals 63. Um, I guess it's a good chance to remind you that these drawings are not to scale. You can't trust how it looks. We just had two problems where in one problem the angle was 54 and in one problem the angle was 27, which is half as much. And the angles look exactly the same. So just because something in a picture looks like it's congruent or looks like it's uh, bigger or smaller than what you calculate, don't trust the picture, trust your calculations. Okay, so to add on to theorem 4.3 and 4.4, we have these corollaries, which are just like a little bit, you can apply the theorem to figure this out as well. And what they are is that if you have an equilateral triangle, then it is also equal angular. So the reason that's a corollary is because you could look at this as an isosceles triangle with these base angles, or you could look at it as an isosceles triangle with these base angles. And by looking at it in those two ways, you can determine that indeed all three angles in this triangle are congruent. And because that's all three angles, you actually know for sure that every one of those angles is going to be 60 degrees, because that's the only thing. That's 180 divided by 3. And the corollary to 4.4, the converse of that, is that if all the angles are congruent, then all the sides are congruent. And these are the things that are true about an equilateral triangle. Equa means equal, lateral means sides. Okay. So, finding angle measures. So in this question, they're asking us what are the measures of angles A, angle B, and angle ADC. Let's see, let's highlight those really quick. Angle A, angle B, and angle ADC. Oh, ADC. So be careful with that. That's actually this one, ADC. And what we just learned is, well, these are equilateral triangles. All of the sides here are marked congruent. So we know that these angles are going to be 60 degrees. And this question doesn't actually ask me to explain. So I'm just going to write down that they are 60 degrees. But that follows the explanation from what I just said. These triangles have to add up to 180. 180 divided by 3 is 60. In an equilateral triangle, the angles are always 60 degrees. Now, this angle up at the top here is a little bit different because here we would have a 60-degree angle, and here we would have another 60-degree angle. So that's our angle addition postulate tells us. We can add those together. And so angle ADC will actually equal 120 degrees, or rather the measure of these angles. Okay. So that's how you can apply what we know about equilateral triangles. The next question here is, suppose the triangles in problem 3 are isosceles triangles where ADE, oh, we better get that picture in here for you guys. Let me grab that really quick. Okay, here we go. So if you suppose triangles in problem 3 are isosceles triangles where angle ADE, angle DEC, and angle CECB are vertex angles, which means you're going to have to figure out, okay, if if you know the vertex, you have to figure out which sides are the legs, and the side that is not one of the legs will be the base. It won't be congruent to the legs anymore. And the vertex angles each have a measure of 58 degrees. Then you have to figure out measure of angle A and measure of angle B, C, D. Okay, so think carefully about that one. And once you're done with that, we've got a bunch of problems for you to practice what you've learned. Oops, I'll do it this way. So here, you have to complete each statement and explain why it's true. You don't have to do a full proof here. You can do a shorter explanation. Look carefully at the picture and use what we have learned. Here is algebra stuff. So we're going to be going back to which angles do we know are congruent, and the fact that triangles add up to 180 degrees to help you answer these questions. Also, you'll see number 11 there is asking you about these two lengths. So let me highlight them really quick. It's asking you about these two lengths. So remember that what we learned about the isosceles triangles, if you have an angle bisector, remember, what did we say? We didn't use it, but we talked about it. What is true about those two lengths? You can look back in your notes or look back in the video to figure it out. All right, and then 12 is another isosceles triangle problem involving the angles, involving a linear angle, or a linear pair of angles there to help you figure that one out. 13, equilateral triangle and isosceles triangle share a common side. What is the measure of angle ABC? So you should be able to figure that out. Here is a cool question about the Great Pyramids. Draw a picture for this one. Think about it carefully. Great Pyramid, yeah, it tells you, will have isosceles triangle. All right, and those are like the Egyptian, the Great Pyramids are the ones in Egypt. Giza is the really famous ones. So if you don't know about that, you should probably look up a picture of it so you have a little bit of context. And then 12 here is developing proof, or sorry, 22 here is developing proof, another isosceles triangle problem, but they've given you most of the proof, and your job is to fill in the blanks here. You'll notice the blanks start all the way up here at draw blank a bisector of the base HJ. So what they're looking for there is, what is the line segment that is the bisector of the base HJ? Then given HK is congruent to KJ, which line segment, which line segment bisects HJ? That's going to be the same answer as you had for A. And then you can use what you know to complete the proof. Okay, good luck with those. Give them a shot. I'll have all the answers posted after you try the questions. And that'll be all for this lesson. So good work and have a great day.